For the next video, we're going to discuss the summary of Chapter 5, entitled Mock Sublayer. So the Ethernet Mock sublayer has two primary responsibilities. The first one is the data encapsulation, then the next one is the media access control. For the data encapsulation process includes frame assembly before transmission and frame disassembly upon reception of a frame. In forming the frame, the MAC layer adds a header and trailer to the network layer PDU. Data encapsulation provides three primary functions. The first one is the frame delimiting. The framing process provides important delimiters that are used to identify a group of bits that make up a frame. These delimiting bits provide synchronization between the transmitting and receiving nodes. Next, addressing. The encapsulation process contains the layer 3 PDU and also provides for data link layer addressing. Then error detection. Each frame contains a trailer used to detect any errors in transmission. The use of frames aids the transmission of bits as they are placed on the media and in the grouping of bits at the receiving node. For media access control, the second responsibility of the MAC sublayer is media access control. Media access control is responsible for the placement of frames on the media and the removal of frames from the media. As its name implies, it controls access to the media, and this sublayer communicates directly with the physical layer. The underlying logical topology of Ethernet is a multi-access bus. Therefore, all nodes or devices on a single network segment share the medium. Ethernet is a contention-based method of networking. A contention-based method means that any device can try to transmit data across the shared medium whenever it has data to send. The carrier sends multiple access collision detection or the CSMA CD process is used in half-duplex Ethernet LANs to detect and resolve collisions. Today's Ethernet LANs use full-duplex switches which allow multiple devices to send and receive simultaneously with no collisions. Ethernet evolution. Since the creation of Ethernet in 1973, standards have evolved for specifying faster and more flexible versions of the technology. This ability for Ethernet to improve over time is one of the main reasons it has become so popular. At the data link layer, the frame structure is nearly identical for all speeds of Ethernet. Then the Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. Then the Ethernet 2 is the Ethernet frame format used in TCP/IP networks. Now we're done discussing the summary of Chapter 5.